Welcome back, chemists. This video, we are now going to determine the subscripts in a chemical formula by using our percent composition that we learned about in the previous video. By the end of this video, you should be able to calculate the empirical formulas for various compounds giving their percent makeup. So we are going to calculate the empirical formula from percent composition. To determine the formulas from percent composition, these are the steps that you need to follow. Step one is that you have to assume that you have 100 grams of the compound. So you're going to change the percent into grams. Step two is to convert grams into moles for each element using the molar mass. Step three is to divide each mole answer by the smallest mole answer. And step four is if you do not have a whole number, because as you know, these are supposed to be the subscripts, but if you don't have a whole number, you're going to have to multiply by the smallest whole number to get a whole number ratio. This one might not make much sense, but of course I'll have an example, so it'll make it a little bit easier to understand. And then finally, 5, you'll actually have to skip to this step if you already have a whole number from number 3. These whole numbers are the subscripts for each element. So let me show you what this looks like. To sum up these steps, this is a really helpful poem that has really helped my students, and hopefully it will help you. First, percent to mass, mass to moles, divide by small, and multiply by whole. So this really helps to summarize the steps that you saw on the previous slide. So hopefully you can kind of jot it down so that you have it as we go through the next example. So here's an example problem. It says, what is the empirical formula for a compound that is 21.2% nitrogen, 6.10% hydrogen, 24.3% sulfur, and 48.4% oxygen? The first step is to convert from percent to mass. And so that's really easy because if you assume that you have 100 grams of the compound, remember the ratio is going to be exactly the same no matter what mass of the compound you have. So we pick 100 grams just because it makes the math a lot simpler. So what that means is if you have 21.2% nitrogen, that means that 21.2 grams of nitrogen has to be present in the sample if you're assuming that you have 100 grams. So what you'll do is you'll just simply chop off the percentage sign and write grams. Then what you have to do is you have to convert from mass to moles. That's the next step in the poem. So I'm going to have to use the molar masses of all these individual substances. So I'm going to convert for nitrogen into moles of nitrogen. And then I'm going to go from grams of hydrogen into moles of hydrogen, grams of sulfur into moles of sulfur, and then finally grams of oxygen into moles of oxygen. The third step is to now look at all of these numbers and pick the smallest mole answer. So if you look at all of these 4 numbers, the smallest mole answer is that 0.758. So what you want to do is you want to figure out the ratio of these substances to each other in the formula. So to do this, you're going to divide each mole answer by the smallest mole answer, which in this case is 0.758. And that's why in the poem it says divide by small. A lot of students tend to forget this step, so just be careful. So I'm going to divide all of these by 0.758. And when I do this, I get 2. I get 7.97, which is close enough to 8. So usually the rule of thumb is if it's 0.9, that's good enough to round up. So if you notice, all of these are whole numbers. So that means that these are the subscripts in the formula. So that's why I'm going to have 2 nitrogens because you can see it's 2 for the nitrogen. It's 8 hydrogens. You can see the 8. It's 1 sulfur and 4 oxygen based off of what we see in our calculations. Let's try another example. So this one is, what is the empirical formula for a compound that is 69.8% iron and 30.2% oxygen? So we'll start the same way, percent to mass. So I'm going to just chop off the percentage sign and write grams. I'm going to go from mass to moles by using the molar masses of these substances. Then I have to divide by small. So notice it's 1.25 to 1.89. So 1.25 is smallest. So I'm going to divide both of them by 1.25. And then the next step is technically multiply by whole if these divisions do not give you a whole number. So the first one will obviously be 1, so that gives you a whole number. But if you notice with this one, you actually get 1.5. So remember, these numbers are supposed to represent subscripts, and we never have a subscript that's 1.5. So it definitely doesn't make sense to have a subscript of 1.5 because it's like you're saying you have 1.5 atoms. So what we have to do to make sure that we get a whole number, we have to multiply by the smallest whole number. So I, for example, would start with 2. If you multiply both of these numbers by 2, you'll see that you will get a whole number for the first one, and you'll also get a whole number for the second one. So, but let's pretend maybe by multiplying by 2, it didn't give you a whole number. Then what you would do is you would have to multiply all the answers by 3. And if that didn't give you a whole number, then you would multiply by 4, 5, 6, etc. So what you want to do is you want to try to get a whole number. But in this case, we could stop at 2 because we got it. And so these are going to be the subscripts. So that means that it's going to be Fe2O3. As usual, with chemistry, it takes some practice, but remember the poem. That really helps my students out, and hopefully it will help you too. Thank you so much for watching. I know you're going to do a great job on this.